And so now we'll talk about the second page of section 1.3 and 4. So we've already used the formal definition of limit to be as x approaches a, there'll be some value L. But what we didn't state, although mentioned in the previous video, is we need the area from the left, because we have a to the minus, to be the same as the area from the right side of the graph. And if both of those are equal to some value L, then the limit itself is equal to a value of L. But if the area from the left does not equal the area from the right, then we say the limit does not exist, abbreviated DNE. So let's look at a couple more examples referring to the graph to the bottom right. First, you're asked to take the limit as x approaches -4 from the right-hand side. So I'm going to come find -4. So I'm looking in this general region of the graph. I'm only looking from the right-hand side. So as the graph is headed down to -4, regardless of what's happening under the red dot, it looks like I'm at a height of -1. So only asked from the right side. I don't need to be asked from the left side. What about if we were going to +5 from the left side? I'm going to come find +5. I'm up here on the graph, and I'm only looking at this section on the left side because of the minus sign, and it has a height of 4. Now these next 4 problems are all related. I'm asked to find the limit of this g function as we approach +1, but from the left side. Here's +1. I'm going to drop down to the graph. Yes, there's 2 spots, but I'm only looking to the left. And so as I travel down the left side until I get to +1, it looks like I have a height of, or y value of, -2. When I'm headed to 1, but from the right side of it, so it's weird, you're kind of headed to the left, but you're on the right side of the graph, I look like I'm across from a y value of -4. So next I'm just asked to find the limit as x approaches 1, neither from the left or the right, but we already found from the left is -2, from the right is -4, and since they are not equal, we state that the limit at +1 does not exist. But what about the graph itself? Is there a y value? Do we place our pen when x equals 1 somewhere on the graph? And because an open circle does not show up on the graph, but a closed circle means we will be putting a dot at +1, -4, the function exists even though the limit does not. Here's another set that are connected. Hopefully you've noticed the color patterns are connecting them. -2 from the left-hand side. Here's -2. I go up to the graph. The left-hand side has a height of 1. -2 from the right-hand side has a height of 1. Since those were both 1, the limit at -2 exists and is +1. But does the function exist at -2? Because we only have a circle and there's nothing else that we can see happening at the line x equals -2, the function does not exist. And one last set of examples. I'm just asked to find the limit as x approaches -3. It does not say from the left and the right, as all the previous ones have done, but I'm going to need to look at those myself. So coming over to -3, from the left, I'm going to hit a height of 0. From the right, I'm going to hit a height of 0. So the limit does exist with a height of 0. What about the function at -3? It didn't ask, but we would have 0. The last question asked, the limit is x approaches 0. Here is x approaches 0. I go down. There is no open hole on the graph, so I have a height of -1.